So today we're going to be looking at scale drawings, which we've been leading up to, and really we've been dealing with scale copies. Scale drawings are the same thing, but they're really actual objects more than the shapes that we've been dealing with before. So, the Westland Lysander was an aircraft used by the Royal Air Force in the 1930s. Here are some scale drawings that show the top, side, and front views of the Lysander. Use the scales and scale drawings to approximate the actual lengths of. Okay, so the wingspan of the plane. So the first thing that we need to do, of course, is to use our ruler, and it says to the nearest foot. So I know that I've got this one scale, and that's in meters, and this one is in feet. So this says to go to the nearest foot, so therefore I'm going to be using that top scale. So if I move this, I can see that it's 1 inch for every 10 feet, approximately. Because don't forget, we are looking at approximate. So the wingspan would be from one end of the wing to the other, and I would say that that hits right about here. So that would make that 4.5 or 4.5 inches, because remember this right here was 1 inch. So because it's 4.5 inches, I'm going to be multiplying that times 10. So 4.5 times 10 equals about 45 feet. Okay, the next one, we are going to have the height of the plane to the nearest foot. So again, we're going to be using the same scale, and this time we're going to be looking at the height. So it looks like the only one that really gives us the height, well, I guess we could use, I think, we could use this, the height here, or the height from here to here. We should get the same answer either way. So the first thing I'm going to do is I'm going to bring my ruler up here. I'm going to turn it. I know I'm struggling to do this a little bit because I've never quite done this before, and I know it looks like I changed the size. I believe I changed it back. And either way, that was that one there. Okay, so the height as measured from the top to the bottom, I would say is about 1.2. So 1.2 inches. And again, 1 inch equals 10 feet. In my scale. So if I've got 1.2 inches and I multiply that times 10, that's going to give me 12 feet. Next, I'm looking at the length. So I think, I can use any of this one, or this one. I think I'm just going to go straight up. I'm going to bring, oh, but wait a second. This is to the nearest meter. So it means I'm going to be using this bottom one here. So I'm going to bring this over here. I'd say that's about 2 inches. So 2 inches. 2 inches equals 7 meters. That's weird, right? Okay, so if I bring my ruler up here, and why they are attached, I have no idea. So let's see what we can do here. Okay, that should have separated them. Let's see. Okay, perfect. I know you can't see what I'm doing here. Maybe you can. I'm not really sure, but let's see. So it's about Oh no, oh my goodness. Let's say about, okay, I think I changed the size of it by mistake. So let's go back and do this again. I apologize to you. You can fast forward through that if you need to, I guess. So I'd say it's about 2.5 inches. So if 2 inches equals 7, so now I'm going to set up, so, so now I know that 2.5 is going to equal some number that we don't know. So, of course, to solve that, I divide 7 divided by 2. And over here, do 7 divided by 2. That gives me the scale, so that equals 3.5. So now I'm going to be multiplying 2.5 times 3.5. 2.5 times 3.5. And that should give me 2.5. Actually, I can just do this. So 2 times 3.5 is 7. Let's go off to the side here. 2 times 3.5 equals 7. And then 0.5 times 3.5. In other words, I'm looking for half of that. That would equal, half of 3 is 1.5. Half of 0.5 is 0.25. So if I add all those together, I've got 7 plus 1.5 plus about 2.5. So again, remember I told you whenever you're dealing with numbers like this to think of them as money. It makes things a lot easier usually. So I've got 7.7 times 1.5, that's 8.5, plus another 0.25. So if I had $8.50 and another 25 cents, that would be 8.75 meters. Now remember, all of these are approximate, so if you got something slightly higher or slightly lower, that would still count as being correct. But if it's some outrageous number, well then you need to go back and see what you did. Okay, so now we've got a blueprint for a room, a rectangular room that's 3 inches long, 3 inches by 5.5 inches. The scale says, just like we had before, says that 1 inch is equivalent to 10 feet. Okay, so that means I'm going to be multiplying both of these by 10 to see the dimensions of this room. So here we go. 3 inches, 3 times 10 is going to be 30 feet by, see now remember this is one of the reasons that we don't use that x for multiplying anymore, because we're using it here when we're talking about the dimensions, and we also more importantly use that x as a variable. So just another quick reminder. So we've got 5.5 times 10. So remember, we're just going to move that decimal. Isn't that fun? So it's 30 feet by 55 feet. Here is a triangle. Lynn created a scale copy of triangle A with an area of 72 square units. How many times larger is the area of this scaled copy compared to that of triangle A? Okay, well, first of all, I know that to find my area of this triangle, and I'm just going to say this because I know some of you are wanting to try and count these partial squares, which is, you know, pretty much impossible to get it precise. So what you really want to do is use the formula that you should be familiar with. That's the height of my triangle. So it's the height of the triangle by the base or width of the triangle. So what I'm really counting here is the 1, 2, 3. So it's 3 units tall by 1, 2, 3 units wide. So I know base times height times 1/2. So it's 3 times 3 times 1/2. 3 times 3 is 9 times 1/2. So in other words, that's 4.5 or 4.5. So that is the area of this triangle. And this is the scale copy. Oh no, this is the original, sorry. The original. And this scale copy is an area of 72 square units. So what I'm going to do is I'm going to divide 72 divided by 4.5. I know what you're thinking. Let me grab my calculator. But we don't use it. We don't need it. Because we know our 9 times tables. We know that 9 goes into 72 8 times. Off to the side here. 8 times 9 equals 72. So there's 8 9s. 4.5. There's 2 4.5s in every 9. So that means we double our 8, and that gives us 16. 16 times larger. Okay. What scale factor did Lynn use or apply to triangle A to create the copy? Well, we know when we're looking at area and a scale copy, we know that we take that scale factor and we square it. Take the scale factor and square it. So that means we have to do the opposite of that, which is called taking the square root of 16. If you're not familiar with that, what I'm really looking for is what number times itself equals 16. Well, hopefully you know that that would be 4. So the scale factor that Lynn used was 4. Scale factor equals 4. What is the length of the bottom side of the scaled copy? So that would be this right here down the bottom. I know that my scale factor is 4, so it would be 3 times 4, which is 12 units. So just to highlight our answers here, because I know they kind of get lost as we go through everything. And there they are. Woohoo!